Did you know? White light is made up of 7 colors: violet, indigo, blue, green, yellow, orange and red, together known as Vibgyor. Each color corresponds to different wavelengths, and they together make up the visible part of the electromagnetic spectrum. The wavelength increases as we go from the violet end to the red end of the spectrum. When light passes through a medium containing suspended particles or impurities, light interacts with these particles and gets scattered in all directions. If these particles are smaller in size, then the scattering is known as Rayleigh scattering. In Rayleigh scattering, the waves having shorter wavelengths get scattered more than the waves having longer wavelengths. To understand this phenomenon, a group of students gathered around a small setup in a dark room. They took a container of water and added a few drops of milk to transform it into a colloidal solution. This medium can now scatter light due to the presence of suspended milk particles. To study scattering, a beam of light from a torch was allowed to pass through the milky colloidal solution. First, a blue color filter paper is placed in the path of the light so that only blue light passes through the solution. The blue beam enters the colloidal solution and strikes the screen placed behind it, creating a bright spot on the screen. The students slowly move the screen away from the solution, and the spot on the screen gradually fades. At a certain point, the spot disappears completely. In the next step, the blue filter is replaced with a red color filter paper to allow only red light to pass through the solution. The red beam now passes through the same solution and creates a red spot on the screen. However, this time, as the students start moving the screen, they see something interesting. The red light fades away much more slowly compared to the blue light. The spot from red light also disappears at a much greater distance compared to blue light. This experiment demonstrated the connectivity between the wavelength of light and scattering. Red light has a longer wavelength compared to blue light, and hence it is scattered much less in comparison to blue light. As a result, red light can travel a much larger distance compared to blue light. The same principles determine the colors of the sky, why it is blue during daytime and red during sunset and sunrise. Through a simple experiment using everyday materials, students witness how the wavelength of light determines how it scatters. And in moments like this, learning truly goes beyond the lab.